Okay, so this is real-time system. So real-time means we want to have so not only to complete with the execution of the task, but also the time, okay, where the result is produced. So operating system, in particular, the scheduler is perhaps the most important component in this real-time system. So example of real-time system like control in laboratory experiment, in robotics, air traffic control, telecommunication, okay, so where we need a very fast response, okay. So correctness of the system not depend only for the logical result but also the timing. The task or processes attempt to control or react the events that take place in the outside world. So meaning this is not only the correctness, like the task is being executed, but it's really the time is really important. Okay, so we need to keep up with the time where the completion of the task is happen. Alright, so we will consider two types of real-time tasks. One is the hard real-time task, another one is soft real-time task. Hard real-time task where the task must be complete, okay, by its deadline. Okay, otherwise it will cause unacceptable damage or fatal error to the system. And another one is soft real-time task where it has the deadline but it is not mandatory. So if it exceeds the deadline, okay, then it will be rescheduled so that it can complete with a new deadline. Okay, and it is what we also term where periodic and aperiodic task. Okay, where periodic means it's usually happen in once per time period. So every 1 minute, for example. And a periodic time, a periodic task, sorry, it has deadline in which it must finish or start. So there is no like periodically happen, okay, but it has a constraint is when to start and when to finish. Okay, so let's see the characteristic of real-time system. So it should fulfill 5 general areas that are determinism, responsiveness, user control, reliability, fail-safe operation. Let's look the first one. Determinism is concerned on how long an OS delays before acknowledging an interrupt. So basically, determination in terms of time. Okay, so operations are performed at fixed predetermined times or within predetermined time intervals. So that one is determinism. Okay, it should satisfy the speed with which it can respond to interrupt. So meaning if there is some problem, how long it will be informed or to react. So what I mean is before is acknowledging that this is interruption happen. Okay. Ya ke? Macam salah je. Bingung. Okay, the first characteristic is determinism. It's concerned on how long an OS delays before acknowledging an interrupt. So it's depending on the time. It's really focused on the time. Okay, operations are performed at fixed predetermined times or within predetermined time intervals. So it need to be responding or something like when anything happen or when it want to execute, it must be having the time limit or time deadline or how the delay that will happen, okay, how long it will be considered that it's still acceptable. So that one is determinism. And the second one is responsiveness. So this is most toward the response time. Okay, previously is generic in terms of time. The second, this is the response time. So how long it will respond. Okay, if anything happen. Okay, so respond in terms of Okay, so responsiveness includes amount of time required to initially handle the interrupt and begin execute of the interrupt service routine. Okay, amount of time to require. So everything is about responsiveness. How it respond, how long it will take to respond. Okay, so that one is responsiveness because this is a real-time process, a real-time system. So it requires quick action. The third one is user control. Okay, how basically we allow this to user to control. Okay, so generally it's much broader, okay, in real time because we are not going to rely on the operating system and the system itself. So it need to be something like user can control, can modify. Okay, so what are the things that we should give to user to specify? So these are some of the example: paging or the process hopping. Okay, what process that must be in the main memory? Okay, what the this transfer algorithm. So this is somehow previously in the ordinary operating system is depending on the operating system itself, but now in real time it's giving like selection of freedom for the user to control. Okay, right. The third one is reliability because most of the real time is really need to be reliable. Okay, because normally it will reflect to the financial the file, the important files. Okay, so like what we have in the air traffic control. Okay, so it's kind of loss of life if there is no updates. Okay, the information is not reliable. Okay, saying that this is the journey takeoff for this flight, for example, but somehow actually there are other flight that going to use the same path. So this is a catastrophic consequences. Okay, so consider some examples example of catastrophic consequences such as financial loss, a major equipment damage, and also loss of life. Okay, the last one is file soft operation. This refers to the ability to system to fail in such a way as to preserve as much capability and data as possible. Because there is a situation where if we detect corruption, it's better to stop rather than continue because it will corrupt more of the file. So need to be stopped. So meaning we need to be failed, stop the system from operating so that it will reduce the failure to happen more. Okay, corruption to the files. Okay, so these are the 5 characteristics of real-time system. Okay, so next we will look at the scheduling of the real-time system.